A network administrator often needs to configure a network management device. For instance, here we have the symbol for a router. And if a network administrator wants to make some configuration changes to that device, one option is to directly connect some device to it so the administrator can make those changes. So we'll show how to do that in this tutorial. We'll also look at some application layer protocols that deal with remote logins such as Telnet and transferring files such as FTP. Here we have a network device. We want to make some configuration changes to them. Perhaps we want to turn the DHCP server that's inside it off because it's going to be used in a business environment and there's a separate DHCP service. So one of the ways that we can make these configuration changes is to directly connect this to a device that allows us to send commands and look at the responses of those commands. Now these network devices today, they're all what we'll call smart devices. And by smart device, we mean that inside there is a CPU and some firmware or software that allows the device to offer many different configuration settings. In fact, these devices have really their own tiny operating system. Years ago, we used to connect such devices to things called dumb terminals. Because these smart devices, they don't have any way for a user to input commands or to look at the output. But they do have a communications port on them. So a dumb terminal was a way where a user could type on a keyboard. Those commands would go to the smart device. The smart device would interpret those commands and send them back to the dumb terminal to be displayed on the screen. So a direct connection is one of the ways that a network administrator can configure network devices today. The communication channel that is often used in these situations is a serial communication standard called RS-232. And this standard uses cables that may look like this. So you may have cables which use what are called a DB25 with 25 pins, and you'll see they come in male versions and female versions. So they also come in what's called a DB9 for 9 pin. This is the female here, the male here. And you may even see a special connector which is used originally designed by Cisco, which is called a rollover cable. And one end of the rollover cable uses an RJ45, which is the same type of connector that a network cable would use. And it has a DB9 on the other end. This end here is designed to go into the network device, and this is designed to go to the terminal that's going to send it the commands. Now the RS-232 standard defined the hardware, pins, how they worked, as well as the format of the data bits. But it didn't totally define the connectors in every situation. So you get a lot of different connectors that are out there. In fact, if you could have a DB9 cable like this with a female on one end, a male on the other, but yet the wires are actually different in the cable. So two cables that look identical but are actually wired differently. So cabling can be a bit of a black art to make sure that, that both ends are actually wired properly. Once you have the cables sorted out, there's also some communication parameters that must be set. And these parameters define the following. They can define what's called the baud rate. And the baud rate is basically how fast the bits are being sent across the wire. Data bits indicate how many data bits is being sent in a chunk of information. You have some options like 5, 6, or 7, I think, data bits. A stop bit indicates the end of the chunk of the information. You can send 1, 1.5, and 2 stop bits. Parity is used for error checking and looking for errors that may exist from one end to the other. So you may have some electrical interference, maybe you have a bad cable, so parity is a way of checking to see if there's any errors in the line. Now these communication standards can have a number of different settings, but the settings that you see here are the standard settings that over time most devices default to. And so usually you can simply connect 2 serial devices together and they'll use these communication parameters. But that's not always the case. So if your serial connection's not working, it may be because one of these settings on one end doesn't match the other. So again, this is a setting that has to be made at both ends. The network device has to communicate at this baud rate, and the terminal that's connecting to it has to also transmit and receive at the same baud rate, the same number of data bits, the same stop bits, and the same parity. All network devices that are designed to be managed have on the back a port that's called console. And generally those console ports are one of 2 types. One is a serial port, and you can tell this is a serial port by this little symbol. It's sort of the 1 and 0 bits being shown one after the other. And the standard, if you have this type of console port, is that it's a DB9. But you can also have a console port that is basically an RJ45 receptacle. The dumb terminal is no longer available, but PCs with the correct software can emulate or mimic a terminal. And these are called terminal emulation programs. Terminal emulation, there's actually many different types of dumb terminals, and a terminal emulator can emulate a number of standard terminals which used to be available. The common is something called a VT100. There are many others by DEC and other older companies, but usually you don't have to worry about selecting a type of terminal. So in the back of the PC, you'll generally notice a bunch of different connectors. Now this is a serial, the standard usually called COM1 or COM2. These are the serial ports on back of a PC, and these are a DB9. On newer PCs, you don't see this connector anymore. You only see a newer serial standard called USB. So you may have a USB only sort of more modern computer. So the question is, how do we make connections to our network device based on what we have from our PC? Well, if we have a serial on this end on our PC, and we have a serial on our network device, it's pretty easy to have a female to female 9-pin serial connector, or sorry, 9-wire serial cable. If we have this type of serial connector on our PC, but we have an RJ45, then we need to use a rollover cable. And you can purchase those from the same companies that purchased or that manufacture the network device. Now there's a bit of an issue if you have a newer computer that no longer has serial ports, and that's very common today. And so what you need to do in this situation is you need to purchase some type of adapter that will create for you a serial port by plugging into your USB port on your PC. So you simply plug this into the port, and then you use your female to female over here if you have a serial port on your network adapter, or you may have to use the rollover cable if you have a network device which has an RJ45. So getting the cabling correct may take some looking around. You may have to order some special parts, but those are generally most of the options that you'll see when you need to connect a PC to a network device today. Once we have the mechanical connection completed, we then use terminal emulation software to provide us with a view of the connection. So in the Windows world, one such program is called PuTTY. And when you're configuring PuTTY, you would choose the serial option, and you would set all the communication parameters, parameters such as baud rate and whatever, to the standard settings, the 9600 baud, the one-stop bit, no parity, and so on. Another choice in terminal emulation software using Apple computers is iTerm2. They both do the same type of thing. And if you have everything connected properly, you have your cables connected up right, you have the software installed, once you start your terminal emulation software, you'll get a window like this. And when your network device powers up, you'll see some text here that occurs, sort of some debug messages as the device is powering up. As you type on your PC, you'll generally log into your network device. So we've put a username here and password, and once that's accepted by the network device, it's sending back some information which is allowing you to configure the device. So here we're going to a higher level security, adding another password, and eventually we're going to send commands that allow us to configure the device. So these are all the steps required to make a direct connection to any smart device and to use a PC to configure that device. The network administrator is often responsible for managing network devices that are scattered all over a building, or they may be in buildings hundreds of miles away. In order to connect to these remote devices and look at their configuration, maybe look at their network statistics, an application protocol called Telnet is used. Now this is actually a session layer protocol. It's called an application layer protocol because if we look at any of the upper three layers, that is the session, the presentation, and the application, they're generally all considered application layer protocols. Session is generally responsible for setting up a communication setting between a client and server, and this is where Telnet shines. So it's a session layer protocol. It's used on the internet or any TCP network, and it provides a bidirectional interactive communication link. So a user can type, and that gets sent, and the smart device then sends back some type of response. So each end both transmits and receives information. Now, setting up a Telnet session can be done with software programs such as PuTTY. And you'll notice that instead of selecting serial here, PuTTY is fairly flexible. It allows us to emulate and be used in some application layer protocols. We would select the Telnet option here, and we also do that by clicking a button here. We no longer use a serial port because remember, this is a remote connection we're making, and we're using our TCP network. So we don't need to worry about a local cable that's going from a serial port to the device, because the device is certainly some distance away. We now specify an IP address for the remote device, or we could specify a domain name if we had a domain name for the remote device. Before we leave Telnet, we need to say that Telnet's not used as much as it once was because it's not a secure protocol. When you connect to a remote machine, you often authenticate with a username and a password. Telnet sends that information in a plain text way that could be intercepted and read by hackers. So there's a newer version of Telnet called Secure Shell. Or SSH. And what SSH does is it immediately encrypts information that's sent back and forth. So even if someone did intercept the packets or information that was flowing on the network that had to do with sending a username and password, it's encrypted and can't be read by anyone. Finally, we'll look at some file transfer protocols. The old standard's called FTP, or File Transfer Protocol. An FTP server allows an FTP client to send and receive files over a network. Now, there are many different protocols that allow files to be transferred. Like Telnet, FTP is not a secure protocol. It will send everything in plain text, so if you have to send a username and password to log on to an FTP site, a hacker could get at that information and read it. So there is a secure FTP that encrypts everything. TFTP is called trivial FTP. Has what's called a smaller footprint. It's a smaller software application that can be included in many routers, and it's often used to send or copy the configuration of a router or to update the firmware in a network device such as a router and switch. It has no security at all, and it's generally used in an environment where you're not worried about security and you want something fairly simple. The HTTP protocol, which we've talked about before, used for transferring web page information, can also be used to send files back and forth. This concludes our look at the most common application layer protocols in use today.